This is high-tech electronics Pune make voltage steady feedback amplifier trainer kit. Here we will perform the experiment for input impedance, output impedance, gain for this amplifier with feedback and without feedback, and then we will compare the results. Okay, we have provided inbuilt power supply. I have switched on the kit, and first I will check the supply is coming properly or not. Yes, 12 volt is coming over here. Now I will apply sine wave input from function generator to the input marked Vi. Then I will connect ground. You have to make ground common for function generator, kit and CRO. Now I am connecting output to channel 1. Here I am applying the input. I am measuring input voltage. Multiplier is on 1 volt and amplitude is 2.2 division, means 2.2 volt is the input. Now I will measure the output. So I will connect it to output. So output is coming square wave, means clip sine wave. Why? Because I have applied excess input, so I will reduce the input now till I get maximum undistorted output. From this level output starts clipping, so I will adjust input such that you will get maximum undistorted output. Okay. Now here output is 1, 2, 3, 3.8 division into multiplier is 2, 7.6 volt, and I will measure the input. Input is 0.1 volt or 50 millivolt into 1 division. This input is 50 millivolt and output is 7.6. From you can find out P upon V is your gain. Now next is input impedance. We have measured output here 7.6 volt by applying input at this point. Now for measuring the input impedance, I will apply input through this Rin and I will measure the output voltage. Now output voltage is reduced and it is around 2 divisions into 2 volt. Sorry, 1.6 division into 2 volt, 3.2 volt. And using the formula, you can call this as a VO dash, and using the formula in the manual you can measure the input impedance. For measuring the output impedance, I am applying input again at the same point and I will connect this load resistance. And I will measure the output. So this you can call as a VO double dash, and by using the formula in the manual you can find out the output impedance. And the last part is frequency response. For frequency response you have to vary the frequency from say 500 hertz. See, I am here varying the frequency from say 500 or 100 hertz till higher side, and again lower side. So you can vary the frequency from 200 hertz to say almost 300 kilohertz, and you can find out the bandwidth by using frequency response graph. You can find out from graph, or you can find out the bandwidth from 3 dB points. The same thing in frequency response, gain, input impedance and output impedance you have to perform by connecting the feedback. So this was without feedback. Now I am connecting this feedback to input, and again I will measure all the parameters: input impedance, gain. For gain you have to apply input here, measure output here. V upon V is gain. For input impedance you have to apply input at this point, measure the output VO dash, and from the formula in the manual you can find out the input impedance. For output impedance you have to apply input here, connect this load, measure the output voltage VO double dash, and using manual or formula in the manual you can find out the output impedance. And for frequency response you have to vary the frequency, measure the output voltage, and plot the graph of frequency versus output voltage. From that you can find out the frequency response or lower cutoff and higher cutoff, and you can find out the bandwidth. And you have to compare all these parameters with feedback and without feedback. Thank you very much.